There were several problems on test number one that many of you missed. I am concerned that some of you didn't spend but 7 to 8 minutes on the test, which is great, but you may want to take your time and make sure that you read the questions carefully, pay attention to the signs, maybe work the problem twice before entering your answer, just to be sure that you get it correct. And there were three that I want to address because many of you missed those questions on the test. The first one has to do with rationalizing the denominator, and the problem said rationalize the denominator and simplify. And it was 7x to the fifth divided by the square root of x. And we know that we cannot have a radical in the denominator of a fraction. And so the easiest way to get rid of that is to multiply the numerator and the denominator by that radical, so because it's the square root. So I'm going to multiply the numerator and the denominator by the square root of x, which gives me 7x to the fifth times the square root of x over the square root of x squared. And I wrote that out because I want you to realize then that the square root of x squared, squaring and square root are inverses of each other. So you have 7x to the fifth times the square root of x all over x. And then I notice that I have an x to the fifth and an x to the first in the denominator. So I can divide out the one. Remember, the rule is you subtract the exponents. There's an understood one here, but I can divide out. So I would basically divide out the x in the denominator, and I'm going to divide out an x in the numerator, which leaves me with 4, or x to the fourth. So I end up with 7x to the fourth times the square root of x. And that would actually be your final answer. Okay. Notice I no longer have a radical in the denominator. I do not have a perfect square under the radical, so I've met the conditions for simplifying. The second question that about half of you missed has to do with factoring. And I think in some cases, maybe you were just in too big of a hurry, you weren't paying attention, that you missed a step. Remember, the first step whenever you're going to factor is you want to look for the greatest common factor. And in this case, you do have a greatest common factor of 2. So the first thing I'm going to do is factor that out. So I'm going to factor out a 2, or divide everything by 2, which leaves x to the fourth minus 16. And then I have to think about that x to the fourth minus 16. And I realize that that follows the pattern for the difference of two squares. And so I can factor that using the formula or the pattern. To get x to the fourth, I would have multiplied x squared times x squared. To get 16, I would have done 4 times 4. One would be a plus, one would be a minus. Notice the 2 tags along. You don't just get to delete it off. Okay, so then if I'm looking at this thinking I'm finished, I want to check to make sure, could I break down x squared plus 4? Because there's a plus sign there, that is not something that I could actually break down again. However, x squared minus 4, again, is a difference of two squares. Okay, so I would have 2 times x squared plus 4, and then I'm going to break down this difference of two squares. To get x squared, it would have been x times x. To get 4, it would be 2 times 2, and I have one as a positive and one as a negative. So ultimately I have 2 times x squared plus 4 times x plus 2 times x minus 2. Now, the order that you write these particular pieces in, there are 4 pieces. The order in which you write those pieces doesn't matter because remember, multiplication is commutative and the order doesn't matter. And the last one has to do with an inequality, but it's an inequality that involves fractions. And a number of you indicated you had difficulty when you had to deal with fractions. And so one of the first things that I would tell you to do is we get rid of the fractions. And to get rid of the fractions, we multiply the entire problem by the common denominator. Well, I have a denominator of 2 and a denominator of 4. And so my common denominator is going to be 4. So I'm going to multiply every piece of the problem by 4. And I'm going to write that out for you. So you're going to have 4 times 1/2 x minus 3 times 4 greater than or equal to 4 times 1/4 x plus 2 times 4. So when we simplify that, 4 times 1/2, or half of 4, is 2x, minus 3 times 4 is 12, greater than or equal to 4 times 1/4 is 1 whole, or 1x, plus 2 times 4 is 8. And then I want to get my x values together, so I'm going to subtract 1x from either side. So I have x minus 12 greater than or equal to 8. Then I'm going to add 12. So I have x is greater than or equal to 20. Okay, so there's my solution written in basic inequality form. If we think about our number line, okay, so we would have a number line. It is equal to, so that tells me that I would use a colored in dot. So I'm going to have a dot at 20 and color it in because it can be used because of the equal. And we want to be greater than that, and greater than goes to the right. And remember, that's going to keep going to positive infinity. So written in interval notation, again, we always read the interval left to right. We start at 20, okay? We have a square bracket because it's equal to, and it keeps going to positive infinity. Okay, so those are the 3 questions that I wanted to address from test 1. And again, you may see some of these on the midterm.